So yeah, hi, welcome to the channel. So yeah, just now what happened was basically I was solving this question. I solved this question just right now. I recorded the video, but somehow the recording got deleted, and I'm not pretty sure like how what happened. So yeah, basically jumping into the question. So yeah, this question is basically time-based key value store. So what it states is that design a time-based key value data structure that can store multiple values for the same key at a different timestamp and retrieve the key's value at a certain timestamp. So basically what it states is that like this, suppose this is a key and we have this value at this given timestamp. So this is what basically it states. So like there are three classes which we need to implement. So the first class is timestamp, initialize the object of the data structure. The next one is like to set the value inside the data structure which we will be using. So like we will have a string key value and a timestamp. So it's pretty obvious that it states key and value pair. So it's pretty obvious that we will be using a hash map here. Now, what sort of value we will be storing to get a timestamp is something which we will be getting here. So return a value such that set was called previously with a timestamp previously less than equal to timestamp. If there are multiple such values, it returns the value associated with the largest timestamp previous. If there are no values, it returns empty string. So yeah, so now it's very much clear that we have to return the closest timestamp which is lesser than or equal to the given timestamp in the get value. So yeah, so one thing is very clear that we need to have a timestamp uh, to be in a sorted fashion to get the closest timestamp value from whatever they have asked for. So one way is to do like I thought like was to like basically have uh, stored it in a vector form the values and like sort it for an every input. So that would basically like to sorting it for an every input will make it like n log n time complexity, and for n input we will have like n square o of n square log n. So this is one of the approach which I thought of first. Now like this will be basically a brute force thought process, but now jumping into like what we can do it like to get it to minimize this, like we can have a priority queue. So like now the question which arise to me was like, should I use a min heap or a max heap? So like why this thought process came to my mind was like because first if we have like n, like we have to get a n by 2 at element timestamp. So like we will need to pop in both of them, we will need to pop a n by 2 element to get the n by 2 plus 1 element for that given timestamp. So here the time complexity final conclusion for me was like it will be basically a very much input based to use a max heap or a min heap. So I thought of like going forward with the max heap only and not like going with the min heap, because they are basically going to give the same time complexity as per my view. So yeah, let's hopping into the solution part, coding part. So let's jump here. So as they have stated, string will be there. Now we will be using a priority queue, priority queue of pair of let's say mm, since we have to sort it on the basis of the timestamp, we will be having int comma string, and we will be naming it as like mm, we will be naming as like a key value pair, something like this, or we can simply put it as mp. We don't need to like too much into this thing. Now this is a DSA one. So yeah, now like setting the value. So we will simply doing mp of key dot push, uh, like since this is a pair and we will be having a timestamp as in first one and like value as another one. So it's very much clear like we got like a key as a string as an input, timestamp as a uh, sorting one, and string as in another pair dot second. Okay, yeah, very much clear. Now first we need to check that if that given string is present or not present. So yeah, what it states is that if there are multiple such values, it returns the associated with the largest pair. If there are no such values, it returns empty string. So yeah, we need to return the empty string here. So like Right, let's find it. Mp dot find key is equal to mp dot end. Now here we need to return the empty string. Okay, and now let's try to pop the element and see which is the closest one to it and lesser than or equal to the given timestamp. Okay, so now let's get while mp of key dot while empty. So while this is not empty for that key, we will be go on performing the operation and we will be popping that element mp of key. So what we will be doing is like we need to store the popped elements also. So vector of pair of int comma string element. So yeah, so let's have popped element into dot push back pq dot mp of key dot friend. So basically we got those element and I don't think we need to have like this one here, like we are not going to, this is already in a pair which we need it, and we will be popping that element mp of key dot pop. So yeah, so we popped that element and we stored it here. Now let's try to get like the closest timestamp. So if mp of key dot front dot first is less than equal to the given timestamp which we need it for. So we will be here basically getting answer is equal to, and like we need to have a variable called as answer to store it. Yeah. String answer is equal to this thing, and like answer is equal to mp of key dot front dot second. So yeah, we got this. Now we don't need to further pop the elements. Now we need to get the popped element again back into the parity queue, and n is equal to popped element dot size. Now for I plus plus. So so yeah, one good practice would be to have a uh, like to have iterator like that thing, but yeah, let's not jump there. Like this is the essay. So yeah, for now let's get popped element into this. So mp of key, sorry, I'm my bad. So mp of key dot push the popped element of I, and like this we can return the answer. I think this should be very much accepted here. Let's see. So yeah, there are some missing factors. So let's get here. Let's store. Okay, we need to. This is a priority. So we need to use top. Okay, again a top. Again a top. My let's submit it. So yeah, that's very much from my side. Yeah, thanks. Yeah, bye.